Hey guys, today we're going to talk about finding the area of a rhombus and a kite, and we'll learn a new formula that works for both of these two polygons. Now, a rhombus is a parallelogram, so if you had the height and base, you could just use that. That wouldn't necessarily work for a kite though. So let's go ahead and learn a new formula. We're going to start with a rhombus, and the way we derive the formula will be the same way we can derive it from a kite. So one of the properties we know about a rhombus is it is a parallelogram, so its opposite sides are both parallel and congruent, and we know all sides are congruent. So these sides are all parallel and congruent. We also know in rhombi, since it is a parallelogram, the diagonals, and we'll call this right here diagonal sub 1, we'll call this one diagonal sub 2. We know the diagonals in all parallelograms bisect one another, so these two segments would be congruent and these two segments would be congruent as well. And in a rhombus, the diagonals also are perpendicular to one another. So here's what we're going to do. We're going to label our vertices. We have A, B, C, and D. And we're going to try to derive a formula based upon the diagonals. So diagonal 1 and diagonal 2 to find the area of the rhombus. Now with this, we're going to break it into two triangles and add them together. Triangle ACD, this top triangle, and triangle ACB. If we add the area of those two triangles, we'll have the whole rhombus. If we look at the area of ACD, well, we would use 1/2 base times height, and let's say we make AC the base, that would be diagonal 2. So the area of this is going to be 1/2 diagonal 2 times half of diagonal 1, because this segment up here is congruent to this segment. They both are half of diagonal 1. So 1/2 diagonal 2 times 1/2 diagonal 1. And the first 1/2 is because 1/2 base times height. This was your base, this is your height of that triangle. So this first triangle ACD, the area of that would end up being 1/4 diagonal 1 times diagonal 2. But we're also going to add the area of triangle ACB. And if you look at ACB, well, its triangle also has diagonal 2 as the base, and then you can use this segment right here, half of diagonal 1 again, as the height, so it's identical to this. 1/2 diagonal 2 times your height was 1/2 diagonal 1, so it's going to end up simplifying to the same thing down here. 1/4 diagonal 1 times diagonal 2, and if we combine like terms, 1/4 plus 1/4 is 1/2. So to find the area of a rhombus, you can take half of the product of the two diagonals. So if you know the lengths of both diagonals, you multiply them together, take half, and that will be your area for the rhombus. Now this formula also works for a kite, and I'm going to show you why. It's because kites have some similar properties to rhombi. So we did a rhombus, now a kite. Let's draw a nice kite here. I'll draw it like that. Ooh, that was terrible. Much better. So here's a kite. Properties of kites. You know that the adjacent sides are congruent, and these adjacent sides are congruent. And we're going to look at the diagonals. We know that the diagonals in a kite... Actually, let's just change colors. We know that the diagonals in a kite bisect one another. Oh no, sorry. The diagonals in a kite, one of the diagonals bisects the other. They don't bisect one another. So like this diagonal here is going to bisect this one. We know that they are perpendicular to one another. So that's like the one little difference between the kite and the rhombus with their diagonals. In a kite, we only bisect one of them. In a rhombus, they bisect one another. But we'll still label, we'll call this diagonal 1, this long one, and the diagonal that was bisected, we'll call that diagonal 2, that whole length. And we can do a similar type of thing here. If we want to find the area of the kite, we can break it into two triangles, and both those triangles are going to have the same base and height. So if we had this little triangle ABC, the area of triangle ABC, well, that would be a base of d sub 1, and then d sub 2 is going to be half because you now been bisected. So the area of this triangle up here would be 1/2 base times your height would be 1/2 d sub 2. So the area of this would end up being, again, 1/4 d sub 1 times d sub 2. And then if you look at the triangle on the bottom, you end up with the same base and same height. So you're going to end up with 2 of them. So our total area is just going to be this whole quantity times 2. Or if you add them together like we did in the last one, regardless, you end up with the same formula. 1/2 diagonal 1 times diagonal 2. So in a kite, if you know the lengths of the diagonals, you can use this formula to find the area. And that's all we have for today. So go try some of these on your own. Have a nice day, guys.